Hello and welcome. I'm Shadow of Shadow Gaming, bringing you Programming with Shadow, episode number 54. In today's lesson, we're going to be looking at our little sorting numbers problem or project we've created here. So we're going to do some cleanup today. We're clean up today and mess around with the bubble sort algorithm a little more, but next time, or we'll plan on to have it ready to go next time so that we can just swap out the algorithms a little bit more easily. So let's just begin. So we'll begin. First thing I want to do is I want to move the bubble sort algorithm to its own class. Not a good reason to do this. I just don't think I want it here because otherwise we'll have all the algorithms here, and I think that's not where I want it. So I'm just going to go here and I'm going to do a new class. There we go. And we'll just say bubble sort. And we'll move it here. We'll grab our whole comment here. Static public static class. There we go. And we'll just call it sort. So let's see. We need to swap. Let's move it to its own class too. We will have a utilities class. A lot of times, if you have a utilities class, it's a sign of a problem. A lot of times, you should see about pulling those into some kind of separate something. In this case, I'm going to use it as is, but keep that in mind that a lot of times it's a sign that you should think your design over a little more. We could probably move this over as well. Let's do. Little is sorted method. What was the other one over there? Generate array. We'll move that for now, but I may not want that one over there. Alright, so now that we've got a static class here, we can go ahead and use those back over in the program. So all we have to do is we can say utilities dot that, and that should be all we need. Utilities, this one's this one. Okay, so there we go. So this one now is bubble sort dot sort. So that makes it a little more complex, but I think that'll be fine. So if we go ahead and run it. We'll say 1,000 times. Okay, I think that'll be all right. So we may want to collect some more statistics there. So right now we're just printing the amount of time it takes. We could also get some averages, max and min, stuff like that. I probably like that. So let's go ahead and do that. So we'll have what type is double. We'll do a list of double times no total nanoseconds. Now we'll just do this, and we can use length since we've seen length times dot last. think this should give us the same thing. Let's run it and see. Alright, so there. So let's see. So here, we'll come back to that. Let's do some more statistics. Let's see. At the end, we'll take the times. Let's get an average, I guess. Maybe that's what we want to do. So we could do GW average run time. We could just do times the average. I think that'll do it. We could grab max and min too. So we could just do times the max. Just use some of them link methods we did other day. Maximum, minimum. All right, so there should give us a little more info. Let's see if it actually works though. There is a problem. In fact, there's two problems. Let's move the sorted check first. And what we'll do here, we'll do this. Let's put an environment new line here at the front. Delete that now. It should have our information a little better. Here, let's put one of them here too. All right, there's just a little more statistics. So what else can we do? Tell you what, let's do a count of let's do an operation count. So maybe not operation. Let's do maybe a count of comparisons. So that would give us pretty good information. Like we would see how many times we've done some kind of comparison in here and get a count from that maybe. Yeah, let's do that. I think that would be nice. So we could have or we might want a second sorting method here for that though. So let's do let's just copy this. And we'll have a don't know sort with comparisons. This one will return a long for the count. That should be an int. We'll do a long though. So there's one. So here, let's just do it here. Int count of comparisons equals 0. Return plus count of. I tell you what, let's just say it's 1 because the first thing we do we do a comparison. So we'll do that. There's 1. So let's do this. So here we do a comparison inside here. So every time we hit this, we do 1. We hit this. Let's do it like this. Let's do it here. We'll delete that one. Do one here. And we'll come back to the swap. We'll do one here, and then one at the end. We'll do it like that, and then we can remove this one and move it in front. The reason to move it in front is we're guaranteed at least one comparison here. We're not guaranteed any more than that, so I think this is how we'll want to do it. Yeah, I believe that's how I want to do it. get rid of the consoles. So there, I think that'll get us a little more information. So now we'll do a number of counts. Let's check the swap method. So there's two ways to do it. We could just, we know there's, is there a comparison? I want to say there is a comparison because that's what we're doing before, but I don't think there is. So maybe not. Maybe we'll forget about that one then. But either way, let's see what this does. So at the end, we'll need to earn kind of comparisons. Okay, so now we've got that. So let's come back over to program. So we can run that one here as well. Sort with comparisons. There we go. There we can now check here. Environment.new line. Number of comparisons. Comparisons. Where did I put that? Move that up here. Long comparisons. There we go. Something like that. Let's run that. Let's see if that gives us any kind of reasonable number. So let's see, for 2, for 2 we should have 1, 2, 1, 2, 3, 4, 5, 6, 7. I think we get 8. So let's see if that's the number we get for 2. 9. Okay, miscounted. So let's see. So what we should be able to see though is that if we run that now, so if there was 2, if we look at 10, 33 comparisons. If we look at 100, 303, 1,000. Basically we have 3,000, or basically we have 3 comparisons for each number. Maybe not exactly, but there's some number that it's going up by, and that makes sense because we have a constant number of, we're always checking because there'll always be 1 here. There's the 1. There'll always be 1 here. I guess there's always this one here. That gives us the 3, and then all the rest of it's the counting. So I think that makes sense. It seems reasonable to me, at least. So now let's make it a way to actually configure that though. So as of that is, it's a little, or we would just have to swap it out manually. Instead, we can do something else. Let's see. We may want to do it manually. I was trying to think of something else, but I don't want to put anything else in the stopwatch. So maybe let's do that. Maybe let's have them both, but maybe we'll think about if we want to do something else. But maybe we just want to do that and just have one commented out for now. The reason you don't want that, you don't want the comparisons because they're actually slowing it down, so we want to leave them without it. Make these. Yeah, I'll think about that. We may still add something else, some kind of logic here to actually pick which algorithm, but maybe we want to just do that manually. What's our to dos? So let's see. So comparison. Nah, I think this is all right. Consider making this configurable. So what we're doing here, we're throwing off the first one because the first one is always a little longer. Let's pull that out just a second, just to show that. If we remember what happens here, the first one will be really long compared to any of the others. The 3 million, everything else is faster because of how the computer does the caching. So yeah, really throws off the average. I think I like that. I think I'd rather keep that in place. So maybe we'll leave that in for now. Tell you what, let's do it like this. Let's do we'll collect it each time. We'll collect it each time, but let's only put it let's only print it otherwise. Now let's print it each time. I'm going back and forth on what I want to do there. So the reason we can do that though is here we can do times dot skip We'll just go ahead and skip the first one for sake of the comparisons. So get rid of the outlier. So let's see if we get something reasonable here. Yeah. And we should print something there to indicate that. Here, let's do this. Put 2 lines there, and then we'll do W skipping one outlier. We'll do that. It does not click that. There we go. Yeah. I think that's a little clearer, so we make sure we note that it's there, but we note that we've skipped it. I think that's good. Okay. But yeah, so I think that's the direction. Let's see, check early. We come back to that. Control duplicates and negative values. Yeah, I like the idea of that. Let's see. Yeah, let's do it. Are them booleans? Do you want to accept duplicates? We'll do it like that. We'll make that a right. Now string Let's do it that, but let's do it dot to lower. Let's do it to upper. There we go. That's saying. Oh, yeah, that makes sense. It's saying it doesn't have to be that, so we'll have to do it separately. Right, numbers. Yes, no. Alright, so now we can pass those in. So I think that's all we wanted. So here we can do this. So we can say accept duplicates. To lower. Let's do to upper. Equals. Yeah, so there. So we turn it to uppercase, whatever they type, and if it's a Y, then yes, we want to do accept duplicates. So yeah, and then allow negative values. To upper. I think I want to do that. So now I think we have control of that. So let's check. We may have to adjust their functions here because I think my sort doesn't count for that. But let's see. Yes, and yes. Array is sorted. Well, let's add a print. We'll add that there. 10. Yes, yes. Very unlikely we're actually get a duplicate there though. So okay, so I think that'll work. So let's go make that actually generate the correct array. So let's check. So if allow duplicates, we just add. That makes sense. So here we're checking that. So we need to control the range though. So here, let's do actually don't think this I think this has to be in integers. So we'll say int start equals 0 if allow negative values start equals int.min value there, and we can actually combine those. So here, the next, so if we pass in start now, what does that give us? It returns a non-negative integer. A 32-bit signed integer that is greater than or equal to 0 and less than the max value. So that's max value, so we need one more. The max value we will do int.max value, if that's the correct one we want. Min and max. Greater than or equal to the minimum value and less than the max value. So yeah, I think that's right. So we can do that in both spots. And there, I think that accepts that. So what we can do here, we can make this a ternary. So we can do allow native values. If it's true, we do int.min value. If it's false, we do 0. I think that gets us what we want to do. All right, so let's do some testing now. So 10 may be too few values to actually do this. So there's some negatives and some positives. Good. And they look hard to tell, but they look like they're ascending to me. So let's do this. Let's scale this down just a second. Let's say there's not going to be an easy way to scale it down. I was going to say let's put it in some range that's easier to actually see, like -10 to 10. I guess we can do that. Here, let's do this. Int end equals int.max value. Now we can just use end here, like that. Now we can just set these. So start equals -10, end equals 11. Now let's just see. Let's see if the numbers look semi-reasonable. 10. Yes, yes. There's just a duplicate, and the numbers look reasonable. Okay. Here, let's run it forever, because we can run it forever with this condition just to show that we can. So let's say we have 1,000. We do not want to accept duplicates, but we do want to accept negative values. And now there's not enough values to populate 1,000 variables, so we got stuck in the loop, so we made us an infinite loop. So this is just constantly happening. Control C. All right. So I think that does what I want it to do. So we'll stop with that. Come back over here. We'll see what this wants. Let's do that. Dot ordinal ignore case. We'll do that. That's just wanting us to use a different comparer, and I don't think it really matters in our case. I think string equals was fine there. Yeah, let's use string equals. The other one's better in general because you get more control of what you're doing, but I think for what we're doing here, this is fine. I'm entering it. I'm not trying to ship this anywhere. We're not trying to use other languages. We're using my keyboard, so I think this is fine for us. So if you ever have an error that you think's all right, but you don't want to deal with, you can come here to this, and you can do something like this. So what this says, Pragma warning, disable this. So there's the message. So we're disabling that warning. So here, let me remove this. Do that just a second. So when we build here, we should see. So we should see, but it didn't show up. Yeah, I missed it at some point. You just do a build solution. Okay, we are not getting them. They must be too low a level. What level do we actually have it at? Severity, so we've got it configured at none, so it doesn't actually show up. That's wrong. It's a suggestion. Oh well. What it's doing is you get to be able to, you can control what you're doing here with that. So you can disable it though, and it shouldn't show up as a warning. It's not showing up as a warning for us anyway. Oh, we can do that. It still wants the other one, but I don't care. I don't think I care about the other one, so that would be the case. I would want to compress or suppress it. There we go. In that case, it wasn't coming through as an actual warning though, so it probably wouldn't. It would be hard to notice. It's like this one should remove an unused parameter, but probably don't care. I'm going to separate these. Move that up. There we go. I'm just making this a little more readable. We do our setup up here, we do this, and then we get their statistics. We can remove the printing over the array. All right, so I think we're actually set up now, so we can play around with some other values. So let's go back to the other one. We'll turn on early ending, and let's see if this helps any. It may not help. So let's see. Let's open up. Let me open up something here. We'll open up a notepad. Or not. There. I'll tell you what, let's just use our text document here. All right, let's do some numbers. All right, so let's do 10, 100, 1,000, and 10,000. I think 100,000 was too slow. All right, so there's some values. So let's see what we get here. So if we run it with 10 elements, no and no. We get those values. I'm going to move these over to the other screen just a second. We'll get there. We'll do count. Int. There we'll do max. Min. Average. Comparisons. The max ended up being 300 nanoseconds. Min ended up being 100. Average ended up being 150. And we didn't do comparisons. So we'll come back to it. So that's the run. Those are the numbers. So we'll run it again with 100. A little bigger. We run that, we get 40. We get 300. We get 470. Tell you what, we'll open an Excel document. We'll just copy this up real quick. Min, average, 10, 100, 1,000, 10,000, 100,000. I'll do 300, 100, 50, 1,400, 300, and 470. All right, so I'll go ahead and take those down, and we'll look at the numbers when we finish. So there's that again. Just cut this out. Don't save. So 1,000. No. All right. what I'm imagining is we're going to get some graphs here that are interesting, I think. Okay. 10,000. Yes. I didn't want to do that. Got distracted. 10,000. No, no. There we go. There's just some more numbers. And let's do the last case, but I think it was too slow, so we may just cancel it. There we go. Yeah, pretty slow. I think once it gets the first one, it should go quickly, but how long is the first one? Pretty slow. So we'll give it a try, but we'll see. So this is just going to get us a rough estimate. It is not a good baseline because I've got a lot of stuff open on my computer. Like I've got OBS recording, for example. I've got some web browsers, so that wasn't too slow. But this isn't a good. If you really wanted to get good numbers, you would turn everything else off, get as minimal system operations as you could, and that would be the better way. Even better would be to have a use benchmark.net, like I said, but it takes a little bit longer to do the setup, and we might look at it in the future, but for now we won't worry about it. Let's go here, collect a little more data, so let's run it with the comparisons. No, it's not. Let's do this. Let's run it this with thoughts now. Go out the early end. Get us a little more data, and we'll play around with the numbers here in just a second. So there is a 400, 100, 140. I'll go ahead and tell you those numbers are about the same. So no. So there's a little interesting. We have two outliers here. Maybe we should be doing a little more on the cutoff, but we did not, so we'll just avoid the first one. There's one really big one, so there's something there, so let's try that one again. There's more in line what we expected. A lot of times if it does one, that means something else spiked on my computer. Maybe my background changed. A lot of times that actually causes a little bit of lag. So what we should be able to see here once we get these numbers is if the early exit actually makes any difference whatsoever. My suspicion was that it would make a little bit of difference. The actual we'll see in just a second, but basically the idea with the early exit was that as we close the list, as we go through and make our comparisons, we have the 2 pointers and we go 1, 2, and we keep comparing and we do it the whole time each time. Early exit, we cut off one last check each time. And tell you what, we could probably just program this to do this for us. So there we have an outlier because I messed it up, opening stuff in the background probably. We'll rerun 100,000 because I did mess it up, and we'll try not to mess it up this time. So what you would expect is the early exit should be a little faster. We'll see if it's fast enough that it actually matters though. What we might can do next though is we can actually take the statistics process here and actually grab those statistics. That might actually be a good extension actually, so we may see how long we've got. There we go. That looks a little more stable. All right, so now we have some numbers. Let's go back over here. Let's grab the comparisons as well. Alt. We'll do that. Another thing we could test, we could see if it does better if the data's done differently. So we could compare it with, say the data is already mostly sorted. Maybe it does a little better there than if it's random. I think for bubble sort, I think it should. We could do, we could have it in the complete opposite direction, see the worst case. Number of comparisons looks stable. That's other things we could do. We can compare it with these two flags here since I wrote them. Yeah. So I think this one's stable actually. I think if we do 1,000, I think we'll get 3,003. And I think that's matching what we got on the other numbers as well. I just noticed a mistake I am doing though, so these numbers aren't good, so we'll need to consider that. 303. Finally, 10. 33. We can do it with the other one as well. True. Not true, it's true. I went to save is what I was going to do there. 10. 33. So yeah, I think these are stable. I don't think we're going to see anything interesting out of these. 303. Yeah. Next will be 3,003. 3,003. 30,003. And 303,000. So yeah, so those weren't that interesting. So Well, that's one thing to keep in mind. My early exit's not actually saving us any cycles, so maybe my early exit's not working. And I think that's actually the case, but we'll see. Once this one completes, let me check the time. Yeah. So we're 45 minutes in, so we are right out of time. So let's just play around with these numbers, and we'll make them a little clearer for next time. So let's do this. Let's do to do take multiple measurements. And then we can actually remove some of this up here actually. Then we don't need to do this. We can just do progressively. All right, let's pull my data down and let's see what we have. All right, so we have the counts here, max, min, average, comparisons, and then without the early start, and the same thing, max, min, average, comparisons. The first thing to note, max, min. So surprisingly, with the early exit, this one's actually faster. So again, that's not a good example. We ran it 10 times, not a wonderful average. Here, a little bit better. This one, on the other hand, actually starts showing it. So it looks better there. But then we fall apart on the next one. So we probably had an outlier here. And average was worse. This one was better. Worse and worse. So yeah, so I think that's not actually working properly. So our early exit, even with our early exit turned off, I think I've got something wrong there. So, and I'm not even looking at the right fields. Okay, never mind that. Except the big one, they actually wore sort of slightly better for the most part. The big one, the small cases and the big case. So that I'm wondering if this one didn't have a good outlier and I just didn't pay attention. But let's look at one more thing. So let's make a graph. So we'll just select these two columns, insert. I don't want that. Let's do this and this. If we can make a decent shot. Yeah, there we go. Do one more line. Let's do insert. Let's do baseline A2 times A2. Been a while since I've done Excel. Forgot my equals. All right, now let's take these. Now let's make that into that chart. Not really that interesting. Thing if we could have the baseline here and show it as sort of basically increasing not exponentially, polynomially, but that's not what that's showing. If we do a chart here, I may have to play around with the data too because we're out of time and I'm not not getting what I want to do. So I may have to think about what I want to do here just a little more, and we'll come back to that. So next time we'll come back to this. We'll actually do our data collection a little more effectively, and we'll actually try to do some graphing here and actually do a good chart, because this isn't indicative of anything. Let's just grab average again just before we finish, and let's just see if it looks even remotely anything good. Something's happening, but I don't think we can see what's happening from this, so we need more data points probably. So we'll call it with that then. So we'll call it here. So next time we're going to do a little more cleanup. I thought I could get it done today, but we actually had more than as we got more into it, I thought of more of what I want to do. So we'll come back next time and maybe we'll finish them. So that does it for today. So thanks for watching and have a wonderful rest of your day.